Dear students, in the last lecture we discussed about the pitot tube, which is a device used for measuring the velocity at a point. Now in this lecture we are going to cover orifice. After completing the orifice, we will open a new chapter that is on flow through a pipe. Now to start with, we are going to discuss orifice. Now what is orifice? Orifice is a small aperture at the side of the tank or at the bottom of the tank through which fluid can come out. Now in this figure we have a tank. In this tank the fluid is filled up to this height. Fluid is filled up to this height, and this head is kept constant even if we have a hole here of this much size through which this fluid can come out. These streamlines are shown here. At this point number 2, these streamlines are supposed to be parallel. When these streamlines are supposed to be parallel, and this is a section where the area is minimum, this point is called the vena contracta. Vena contracta. So where we have a minimum area, that section is called vena contracta. Though in this flow passage, this opening, if we see from this side, then this is a circular section, this is a circular opening, and it is having very sharp edge so that the contact between fluid and the metal is minimum. Now though the passage area is minimum, which is equal to the pi by 4 d square, where d is the diameter of the orifice, but because of the inertial effects, these streamlines, they are getting converging here. So they keep converging because of the inertia effects, and because of the viscous effects, this conversion is happening up to certain point only. Had there been any inviscid fluid, then they would have been converging continuously up to infinite distance. But because of the viscous effects, the convergence remains up to certain point where the velocity is having only one component. At this section of the vena contracta, we have the one component of velocity, that is only in the horizontal direction, right. So this jet is having velocity at the vena contracta in x direction only, right. So though we have a minimum area here at the orifice, but because of the effect of the inertia, we have a minimum area here which is known as a vena contracta, right. At vena contracta, the velocity is having one component and all streamlines are parallel and the area is minimum. These are the condition of the vena contracta. Now when we have a flow out of this orifice, this head of liquid, so let us say suppose in this example we have a water, then this head is kept constant, and if this is designated by H, and if we have these 2 points, point number 1 and point number 2, then by applying Bernoulli at point number 1 and point number 2, we can develop the relationship for finding out the velocity in terms of this H. So how can we develop the relationship for finding out the velocity V, which is function of H? This can be done with the help of Bernoulli's experiment or Bernoulli's principle. What is Bernoulli principle? P over rho g plus V square divided by 2g plus z is equal to constant, means pressure head, velocity head and potential head, summation of these head must be constant, right. So let us apply Bernoulli equation between point 1 and point 2, where 2 point is at vena contracta, right. So, if we compare with reference to 2 point, then one point is situated at Z1 distance. This distance is Z1 in a perpendicular direction, right. So, let us apply the Bernoulli principle at point 1 and at point Wiener contractor, right. So, at point 1, what is the pressure? P1. So, what is pressure head? P1 over rho g plus velocity head. If velocity at that point is V1, then V1 square divided by 2g plus Z1 is equal to, what is the pressure at the Wiener contractor? Pressure at the Wiener contractor is atmosphere. At this point number 2, the pressure is atmospheric because it has come out of the tank and pressure is atmospheric pressure, right. So, pressure is atmospheric. So, P atmospheric divided by rho g pressure head plus, if velocity is say, let us say V2, at point 2 we are designated that at Wiener contractor velocity is V2, then V2 square divided by 2g plus 0, because with reference to this label we are calculating the Z1.